system at the end, which will pull out one of the attendees who've ticked the box to say that they want the JetBrains license. We've got that handy, so we can give you that at the end. And yeah, it's, for those who don't know, it's great to have. It's usually about £100 to acquire a license, and you can choose from a vast majority of different products that they offer, and there's probably a lot more than these as well, so they're really good. Coming up, we've had a lot of interest for this already, actually, but if you wanted to come and present, and not the whole 1 hour, an hour and a half, this is something that might you'd be interested in. So in October, we run every year, we run lightning talks. This is like 5, 10, 15 minutes of something interesting you want to pitch to get up and get exposure to presenting. And it's a good skill to have and learn. And, you know, some people are going to be nervous. It's their first time. That's exactly what we're expecting. People just get out there and try something new. So if you're working on something, a little passion project, reach out to us. We can give you a slot, but we'd love to, yeah, have you doing a talk for us in October. And yeah, it should be fun. So as well as that, come and support your local community and yeah, help come and book on in October. And other than that, I'm going to pass you on to Dan. Just to be aware, this is going to run a little bit differently. We're going to have a break because of the length of the talk. We're going to have a little comfort break halfway through, so feel free to get some more pizza, drinks, use the facilities just around the left, the toilets and stuff. And then we'll be back after about a 5-10 minute break there. I'll pass you on to Dan. Thank you. You. Ah.
I mean, honestly, I don't think I can go an hour without using the toilet. So it is as much for me as for anyone else. Is it down to go down? Yes, it is. Bosh. Restart the time so I know where we're at. All right. Hi. My name is Dan Roberts. My talk today was advertised as Measure or Miss Why Metrics Matter in Software, because Josh felt it might do better for SEO and it might be easier for people to find on the YouTube channel later on. But my original title was, if you don't know how to measure success, you are doomed to failure, because I thought it made a topic that might sound kind of dry, sound more fun. To be honest, even I thought that was a little bit excessive. And the reality is you're not doomed to failure if you don't know how to measure success, whatever that means. But it does mean that you're likely leaving money on the table. You might mean you, the individual, you as in your department, you as in your entire organization. All of these yous may actually be falling foul of not wanting to measure just how successful your work is or isn't, because frankly, it can be more comfortable to presume that you know what you're doing. And you can still succeed without measuring. It's just you probably aren't succeeding as hard as you could be, or you might be not succeeding in the ways that you think you are. Like, for example, stockbrokers have a low success rate for people who want to jump into the exciting sounding world of investing, but who don't want to pick stocks themselves, which you shouldn't do. But who also don't want to just do something boring like put your money into index funds and be patient, which you probably should do. In fact, only 10% of them are able to beat the market once their fees are taken into account. So they're not succeeding for their clients, but they are succeeding for themselves, according to Wolf of Wall Street. I'll be talking today about what it means to succeed and how you can try to recognize what's valuable to you, again, you, yourself, or your department, or your org, and what sort of things might lead you down blind alleys and be a massive waste of your time. To give you some context, let me tell you a little bit about myself. It's my talk. Hopefully it will give you some insight into where I'm coming from and help you work out whether or not the things I'm going to talk about seem familiar, and whether or if our experiences are just different enough, you're going to have a lot of awkward questions for me at the end. As a staff engineer at Stack Overflow, I'm largely specialized in things relating to search. Now, this is often around text search, like type some words into a text box and hit search and see some results, but it can also be like filtering results and filtering content, or it can be about displaying content that we hope is interesting to you, even if you haven't explicitly searched for anything, you know, like recommendation reels that you've seen on websites. I focus on search across a bunch of jobs for more than a decade now, probably. And it hits two areas that interest me. There's often traffic load, like lots of performance excitement, and user happiness. Now, if I'm being honest, it's more like user misery reduction. A bad search can make your day miserable. A good search, you're just like, and what? I like the optimistic phrasing. In fact, I gave a talk at .NET Liverpool about my adventures with search at Stack last year, but I have a confession to make. Bomb, bomb, bomb. As of last week, I've embarked on a new adventure and I am back living in startup land. So anyone that's come here hoping to meet someone from Stack Overflow, sorry, not sorry. I'm still essentially working on search, but in a slightly different capacity. Now, I prepped all my content before even contemplating this move. So I'm still going to be telling Stack stories, and I probably won't get a chance to touch on what I'm doing now, which is kind of a pity. Sorry, some audio there. It was just water in the pipes. I was like, something weird going on. Which is kind of a pity because it might reinforce that today's topic around measuring for success is not specific to Stack at all, and I will be applying it elsewhere. But I already have a lot of content to get through, so we do not need any more twists and turns. So, as I was saying, I gave a talk here last year about semantic search that I'll try not to repeat too much of here, but some of it is pertinent to my journey, and so I'll be attempting something of a whistle-stop tour. So if you don't know what semantic search means, don't worry, I'll be recapping the big things. If I skim over anything, any details too quickly, then it's only the gist that's important. Because I really want to talk about how it's just one piece of a larger puzzle. In essence, semantic search aims to do a better job of matching words and phrases in a user's query, something you've searched for, to content in documents. By documents, I mean all of your data. In a minute, I'll be taking us on a trip down memory lane about life before semantic search, which is going to be in service, I promise, of getting into the conversation, what's next for my team. We found that semantic search was a great addition to our toolbox, but we still have lots of people that struggle to find what they want, whether that's people using the search box or if it's someone building a new piece of functionality, like another team building something on top of search. They don't feel it's giving them the quality of results that they need. Now, the landscape of tools that we could try to add to improve our search is enormous. It's hard to know where to begin. I could take the approach of, hey, I read this blog post and that sounds really fun. Let's just try replicating that and see if their solution happens to solve all of our problems. And, you know, spoiler alert, it probably won't. So how should we work out what to pursue? Now, again, I want to explain the sort of worlds that I've worked in, because if they're really different to you, I still hope there's going to be topics here that like speak to you. But I figure it's better to work out up front what you might expect, you know, whether you expect it all to feel directly relatable, or if you're going to have to put a bit of imagination into picking out what could be valuable for you. I've worked my entire life on long-lived software that evolves and expands to fulfill customer needs for various types of customer. There's a lot of work, though, around shorter-lived software. Kind of like you configure something for a client, you prevent it breaking for 3 years, you negotiate again, and you repeat, often starting afresh, throw away all that code, never have to support it again. And these contracts often only work with the promise of like upfront, tightly scoped functionality. They often focus on specific features rather than starting with the premise of, we want users, customers, whoever to do X, Y, Z. So how can we do that? There's a big market for that sort of thing. But for now, if that sounds familiar, let's pretend it doesn't, or let's pretend those customers are more interested in paying you for partly for features and partly for your creativity in solving their problems, or that you're working on long life software, or both. I want to start with a couple of definitions. Outcomes versus outputs. Outcomes are measurable user impact. They're not how many things did we ship. Outcomes can be like, company made 10% more money this year, but it's hard to directly tie changes to such high-level measures. Outcomes specific to Stack, which I'll get into later, tend to relate to user behavior and to content creation. An outcome for a shopping site could be increase the number of sales of products that were purchased as a result of a click through from a recommended for you list. Outputs are easier to measure, but they're generally no more than an approximation of value. Did you deliver 10 things? Ooh. Did we make any money off them? Before I go any further, I'm going to take a detour, dive into the past. I keep mentioning this semantic search, which as if it's kind of new, it's kind of blown up in the last few years. What was search before if it wasn't semantic search? It was referred to as lexical search. The word lexical meaning relating to the words or vocabulary of a language. So you break down all your documents into individual words and you stack them in a data structure that makes it really easy to get a list of documents that match any single word. And then you perform a search by breaking your query into words and seeing which documents match all of those words. There can be some flexibility in the matching, like ignoring case. If you type Dan with an uppercase D in the search and someone rudely had typed Dan in a document with a lowercase d, we can ignore case. We can ignore verb endings like draw and drawing. They're the same. Plurality, cat, cats. But it's all quite basic. In fact, like Google's innovations right back in the day weren't so much about matching text. It was about gauging weight or authority of pages and then seeing what pages linked to what other pages. What Google did that was really clever was being like, this site is an authority, whether it's like, this is because it's Microsoft or because loads of other sites link to it. And then they said pages that this authority linked to are probably something of an authority. Pages that are linked to from there are kind of an authority. And you make this big web and network of passing through authority. If you've ever talked to an SEO person and heard the phrase link juice, that's kind of where that came from. What I also think was really clever is that there were two founders of Google, Sergey Brin and Larry Page. And Larry managed to convince Sergey, hey, since our clever algorithm is based upon how pages are linked together through a network, we should call it PageRank. It being my name is just a complete coincidence in your face, Sergey. I don't know if anyone else remembers or ever used the Ask Jeeves search engine. Apparently it predated Google, but I don't remember having used Google. I remember having used Google for years before I'd even heard of this Ask Jeeves. And its USP was that you could ask it questions in plain English. Why is the sky blue? It felt more intelligent almost for this. I don't remember actually giving results to Google, so it was largely a novelty. But this phrase, natural language queries, is another way to say questions in plain English. I mean, they don't have to be questions. When we're talking about searching, they tend to be questions. It doesn't have to be English. I just mean like naturally human spoken languages, not having to pick out keywords. Sky blue. Why? And people are used to giving natural language queries to Google now and to lots of search interfaces, really. Semantic search tends to do a better job of handling natural language queries than whatever I was just thinking. I lost my train of thought. Semantic search tends to do a better job of handling natural language query than lexical. If you've got a lexical search, you ask it a natural language query, it doesn't always do well. You've got a semantic search, you ask it a natural language query, it handles it better. So here we go. We're going to do a lightning recap of what semantic search is. First terminology to introduce. An embedding vector is a piece of data that represents what is important about a piece of content, which is, I'm going to consider it as text, but it could be images, it could be video, it could be audio. We're just thinking about text today. The vector part of embedding vector means it's a piece of data that's a list of decimal numbers. In .NET speak, this is a one-dimensional array of floating point numbers. An embedding model is essentially a piece of software that's able to take content, such as a text document, and calculate an embedding vector for it. We don't need to worry about the process of how that happens. Let's just consider it a black box. You give it text, it gives you an embedding vector. Embedding models are trained by looking at loads and loads and loads and loads and loads of content. And it tries to build up a picture of what words and what word combinations and what sentence structures are interesting. And it will use this when it starts its life calculating embedding vectors. Training a model, an embedding model, it's generally performed only once, and it's not something you or I ever likely to do. You can download pre-trained models that are publicly available. To make use of an embedding model, you go through all your source data, whether that's blog posts, whether that's products for sale, whether it's houses to let, whatever your data is, and you calculate embedding vectors for them, which you store in a vector database. There's lots of vector databases available. Postgres has an extension called PG Vector that will do it. Elasticsearch has support for vector search now, and that's a managed service. Redis will do a managed service. There's loads. For playing around in the local .NET environment, we are at .NET Liverpool. I'm trying to make a few tenuous links. You can try the Microsoft .semantic kernel NuGet packages to get started. There's an in-memory vector store to make it like really easy to get going. I've actually got a demo repo on GitHub for PG Vector. I've got code in my GitHub that uses an in-memory store to add semantic search to my blog. So obviously that means there's a shameless plug to my blog at the end. There's a references slide at the end of the presentation for anyone who is desperate to know more about that. To perform a semantic search, you take a query, you take this text query, you take what this text that someone's searching for, and you calculate an embedding using that embedding model. And then you look for the closest vectors in the vector database. The vectors in the database that are closest relate to documents that are most similar to your query, and so they should be the best results for your query. When I say closest vectors, if we imagine every vector was just like two-dimensional, then you could plot them on a graph, and it would be like the distance between 2 points. And that's maths that we all learned in school. If the vectors were of length 3, it would be like in cube space, and it's still the distance between 2 points. The query point is here, close result is here, far away result is here. Embedding vectors tend to have lengths not of 2 or 3. They tend to be hundreds or thousands, which our little human brains aren't very good at picturing. But similar principle applies. Because embedding models are trained on lots and lots and lots and lots of content, they're really good at being flexible with typos, with regional spelling variations, things like that. Like where it's the same, it means the same, but it's a bit different. But they're also really good at differentiating meanings of the same word. The words kid and pen have multiple meanings, but in the context of the question, who is responsible for locking the kid pen? Kid pen more likely refers to an enclosure for baby goats than to, well, I asked Gemini to draw me a lockable pen for children. This is what I got. I don't know if many of you use Gemini or AI image creation to jazz up your presentations. I think it's fair to say you get mixed success. If you try to locate documents using a lexical search against this query, who's responsible for locking the kid pen? It would split it into individual words, and it discards all the context about how those words are used. So the lexical search very feasibly is going to do a ropey job, whereas the semantic search does a better job of understanding what kid pen relates to. To really drive the point home, lexical search would likely consider the first snippet of text we have up here to be a good match. Did you leave Dave's kid's felt tip pen in your locker again? Now, this is a nice example because it shows the little per word flexibility of lexical, locking and locker, kid and kids, but it doesn't understand that it's the wrong meaning of the words. And it also won't understand that goat enclosure, totally different words, and kid pen are similar concepts when used in a sentence. Don't forget, the lab staff must ensure that the goat enclosure is not left open at the end of the day. Semantic search can do that. So, cool, right? Yeah. Well, there are some complications. There's a lot of embedding models that you have to choose from with different strengths and weaknesses. Different vector sizes mean different storage requirements, different search speeds. Some models are English only, some models are multilingual. Embedding models tend to have content size limits. Lexical, you can take a document as long as you like and break it up into words, but semantic, if there's too many words, they just forget the ones at the end, and so long form content you have to split somehow. And said that semantic search works by giving you these closest vectors to your search, but it could only tell you what's closest. It doesn't actually say, is this good? Closest, the top 10 closest results might just mean the top 10 least awful results. And although it's just maths, it's just calculations, surely numbers are reliable, the scores you get from semantic search do not carry across from one query to another. That sounds really complicated and confusing. What I mean is, for one search, if you get a score of between 0 and 0.8, they might all be terrible, and between 0.8 and 1, they might be good. But for a different query, all the way up to 0.9 might be terrible, and from 0.9 upwards might be good. So this closest vector idea has its limitations. So where are we with semantic search at Stack Overflow? I don't know if you all know, if you came to my last talk, you'll have heard this over and over again, but there's a few familiar faces, but not many. Stack have a private product called Stack Overflow for Teams, which is like customers or companies who want to have their own private Stack Overflow site for sharing knowledge about internal stuff. I don't know if I'm actually allowed to name many of them, but you would have heard of lots of companies who have their own team site. We've historically used lexical search there, and it is okay, I guess, at best, if you're good at crafting keyword searches and you know your data quite well. You've probably never noticed how tedious it can be crafting searches in our search bar on the public site, because Google is effectively the search of our public site. But since the data is private in these Stack Overflow for Team sites, Google can't index it, customers have to use the on-site search, and it has long appeared in user research as this is painful. So for our top tier of paid customers, we implemented semantic search, and it's done well. Teams data tends to be a bit different from our public data, which I'm going to talk about in a moment. They don't tend to have lots of answers for questions. If someone asks something, maybe there'll be an answer, and it will remain the only answer. There won't be like multiple answers. And there doesn't tend to be lots of content that's outdated. There doesn't tend to be any old content. And there's very little low quality content, because there tends to be a smallish group of people who are like contributing to it, asking stuff and answering it and curating it. Quite often they'll know each other. There's pride in the quality of what they write. The biggest hurdle for search on Teams is finding content that exists. It tends to be good content, but finding it is hard, rather than there being too much content out there which needs lots of sifting through in order to work out what's still relevant. So, and another aspect of success with semantic search for our Teams product was the introduction of enhanced search, which was a product, that's what it's called, enhanced search, really creative, exciting naming. It's a product built on top of search by one of the other teams. It's essentially an AI summary like you see in Google search results these days. It uses a strategy called RAG, which stands for Retrieval Augmented Generation. What this means is you can ask an LLM to answer any question, and it will try to like conjure something up based upon whatever data it was originally trained on. And for some queries, that can be really effective. But for other queries, it can give you terrible answers. Retrieval Augmented Generation says, will you try to answer the user's query, but only using this data, only using these search results that I give you? Because like that vector distance, and like we don't know where this confidence threshold should lie in the numbers, when you ask an AI, when you ask an LLM to answer something, it's always super confident. There is no confidence threshold. So RAG is an attempt to be a little more controlling. It says to it, only use this content. And if you can't answer it using this content, you need to say, I'm sorry, Dave, I'm afraid I can't help you with that. This can make life easier for our Teams users. And like Google has this feature, yeah, but Google can't index the private data, Teams data. So semantic search on Teams. What about on our public site? We have experimented with semantic search on our public site. Terminology thing, we call our public sites the public platform or pubplat, or sometimes the community product or cprod as opposed to the private product, which is Teams. So if I use the terms pubplat or cprod because I forget who I'm talking to and that you don't know all this lingo, now you know what I mean. Now the eagle-eyed of you may have noticed this part 2 was from 2023, whereas the Teams work, part 1, was 2024. So this work actually came first, but I wanted to start this section of my talk on a high. The Teams semantic search still exists. The pubplat one was turned off. Why? Well, it was partly an attempt to win back traffic from ChatGPT rather than to solve a real user problem, unlike in Teams where there's a real user problem. And while it did a good job of finding answers similar to the question you asked, it turns out that the most similar results are not the best results. They might be really old, or they might be terrible answers that use a similar phrasing to what you've asked. Now, we could use metadata like, was this an accepted answer? How many upvotes has it got? Blah, 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 blah. But it was decided that further investment wasn't going to bring sufficient return for this pubplat semantic search. While we're experimenting with it, we tried to see if we could enable a sort of chat UI to help people find content, but that's a whole thing on its own. Search and chat feel similar, but they're not. And the alpha demos we didn't get much traction. So we abandoned chat. Should we have kept maintaining semantic search for the people who use our site search? No, I don't think we should have. Even with lots of vector database provider options to support you, it's still not free. Embedding generation incurs compute cost, and the vector database offerings, they come from providers. Some of those providers are new, or they specialize more in lexical search and they're dipping their toe into vector search. They're not always very mature and reliable. So maintenance isn't free, takes resources away from teams who could be doing more valuable things. These stats, by the way, just for our one main site, stackoverflow.com. And they don't include page requests that we think come from bots or from scrapers or web crawlers. So the main site is our biggest by far. If you don't, we have hundreds of sites that cover topics like coffee, car mechanics, mathematics, all sorts of things. But focusing on the main site, on an average day, we get 8 million question views. 70% of them are from people who clicked a link from a Google search. 0.16% are the result of someone performing a search on our site and then clicking a result. It's roughly 30,000 on-site searches a day, which isn't really nothing. Like, I've worked on products before where I'd be like, 30,000 searches today. But in the context of these numbers, it is effectively zero. These facts led to pubplat semantic search being abandoned. To recap, we didn't continue investing in it to integrate those quality signals to make the ordering of results better. This contributed to the failure of the chat experiment. We really wanted a trustworthy experience, kind of RAG-like. So we need the best content in order to avoid hallucinations, but we weren't surfacing those best results. And nobody uses site search. So why keep semantic search when chat was axed? Because let's be honest, we can't compete directly with Google like that. Google not only has decades of search experience, they have massive resources. And they're searching over the entire internet. The content that Stack has, it can give you really good answers, but there are huge swathes of topics that we just don't have content for. There's poor coverage of lots of programming languages and libraries. Have you ever tried to search for ways to solve problems with the language Zig, for example? I bet you didn't find the answer on our site. And when I talk about Google's resources, you might not know that Stack only employs a few hundred people, like 50 developers out of that, maybe 60, which is not enough to compete with the big players if they're all, even if all of them were working on one project. But that's the devs for everything. Now, it's not all been doom and gloom. Because those 2023 experiments taught us quite a lot. They taught us how to implement semantic search on Teams, which has been a big benefit to our users. When you use these embedding models, you need to give it one chunk of text. So it taught us how to, we did some experiments with, if each answer is not just the answer body, but it's tied to a question, and a question has a title and a body, and you want one piece of content to shove into the embedding model, should you, to try and capture the context, maybe have the question title, and then the answer body, and then the question body, because you need to concatenate it somehow. Yeah, whatever. We did some experiments, we learned that, we took some things away. I said that there's a limit to the context size you can put into an embedding model, so you have to break up larger content. We learned some stuff about that. We learned that sometimes lexical search is better. When you do keyword searches, which people still do keyword searches sometimes it's better. So maybe we should try to do like a hybrid search, which is like do a bit of semantic and a bit of lexical. And we learned that sometimes the most similar content is not helpful. It can be this case, this least bad case. And it can be that the least bad results are all awful. And we should do something about that. I mean, would you want the least bad results from a query like this? Advantages of eating popcorn while writing jQuery code in Rust. Sometimes you just have to say there are no good answers here. Search over embedding vectors always return results. But like I said earlier, we have no way to know if the top 10 are good, bad, somewhere in between. We address this. We needed to introduce another piece of the puzzle. And I promise you, we are on the way to the point of this talk. It's not all about search either. Performing a vector search is relatively cheap. More expensive than lexical, but a downside is that it's an approximation. Those embedding vectors try to capture important concepts from the piece of text that you've embedded, that you've created the embedding vector for. If they're limited in size, and we know that these vector distance calculations are not values you can reliably interpret as good, bad, blah. So we use something called a semantic re-ranker, sometimes referred to only as a re-ranker. A re-ranker can take text documents and a user query and do magic and give you reliable scores where you can say good, really good, not so good. But it's expensive to compute. So we kind of refer to this as we've got this massive pool of data. We do a vector search. We cast a wide net to try to shrink this massive set to a smaller set, and then we can give that smaller set to a re-ranker. It's too expensive to just give all of your data to a re-ranker. So cast a wide net, it's approximate, give it to a re-ranker, it's boss. I kind of had to think for a while to come up with that example of advantages of eating popcorn while writing jQuery code in Rust. It's weirdly hard to put together a query that feels like it could be reasonable, but which on our site, it definitely isn't, on our main site. Because for our Teams products, the amount of data is so much smaller. Like our largest customer has 400,000 questions and answers. StackOverflow.com has 60 million questions and answers. Now, the less data, like on a Teams site, the less data and the fewer subjects, the more often you should admit, sorry, no good answers are available, particularly if you're feeding the results into a RAG system. Because when the source data is poor, whatever summary is produced is going to be terrible and potentially very confusing. So a semantic re-ranker for Teams was crucial. Now, you can see on the diagram that we perform a semantic search and a lexical search, and then, because people still do these keyword style searches sometimes, and lexical's better for those, then we combine those two sets, pass them to the re-ranker with the original query, and it returns a new ordering for them with reliable scores, so we can say, don't include this result, it's crap, but do keep these ones. Did the re-ranker completely solve the problem that sometimes the most similar content is not helpful? No, it did not. When the most similar content consists entirely of terrible results, now we can say, sorry, I can't help you, which is one piece of the puzzle. But sometimes there is great content in there, but there's content more similar to the query that's less good as an answer to that query. Imagine you're on PubPlat and there's a question very similar to what you've typed into the search box with two answers. The first answer is excellent and it explains the root cause and it provides a solution and people have upvoted it a lot. The second answer basically restates the original question and provides at most kind of a hint on how to answer it. The second answer's content will be more similar to what you're searching for, but the first answer will be much more helpful. Or maybe the first answer was excellent 10 years ago, but there's a newer answer that has an approach for modern libraries. Now, this isn't the biggest problem for Teams because no customer has 15 years worth of data. Teams didn't exist 15 years ago. And few customers actually have questions with lots of answers. But we are exploring again, improving search on PubPlat. And our 2023 foray into PubPlat semantic search taught us semantic search on its own is not adequate. At the minimum, we're going to need some sort of metadata re-ranker, where the semantic re-ranker allowed us to easily combine semantic search results and lexical search results, compare them to each other, discard terrible results. A metadata re-ranker would allow us to alter the results order again using data about the content, i.e. metadata. Meta meaning about, the data being the data, metadata, data about the data, such as recency, votes, etc., etc. There are quality signals that we can use to rearrange our most similar content such that the best content appears higher up. If these results are going to be shown in a search results page, if these results are going to be shown in a search results page, the user hopefully only has to look at the top few. If the results are being fed into something like a RAG system or consumed by a third-party system to do whatever third-party systems do with our search results, they might only look at the top 3 results, so they better be good. Easy peasy. There's only a few blocks on this diagram. How hard could it be? But I mentioned earlier about the decisions that go into picking an embedding model and a chunking strategy. Well, now you've got even more things to pick. Different models for metadata re-rankers, different decisions for incorporating the metadata signals. Like if there's 2 competing answers, one's been upvoted 800 times, oh my God, but over 10 years and nobody's upvoted it for ages, and there's a new answer that was written 4 months ago that only has 150 votes, which one's best? 800 versus 150, 800 that are old, 150 votes that are new. I also mentioned before that you can configure lexical search to be forgiving around like plurals and verb formations. You can also configure it to be forgiving around synonyms and typos, but the more options you enable, the more weird edge cases you can encounter. And I'm not going to go into that further, it's a whole separate discussion. Suffice to say, there's a lot of decisions to make, even just implementing a lexical search. So this is quite a list. If you were coming at it, how would you know where to start? How could you compare one choice or even one set of choices against another? Which sounds like I might actually be getting back on track with the subject of the talk. Well, I'm afraid we've got just one of many. More detours yet to go. Performing searches in a vector database is relatively cheap, not as cheap as lexical, but it requires you to have a vector database and maintain it and populate it and keep its data current. There's cost to set up, there's cost to keep it running, and I'm talking about time and I'm talking about money. What if we wanted to experiment with enabling semantic search on your data, but you didn't know for sure that you wanted to pay these big upfront costs? One alternative is to take a user query, ask an LLM, hey, can you generate a lexical query from this, or can you extract keywords from this? And then use your regular lexical search, which will be a very approximate version of a search. So you'll want to overfetch lexically to get good results. I'll explain what that means in a minute. And then you'll rely on a re-ranker even more, because you're no longer kind of hoping, I reckon I've got some good results here, and you, the re-ranker, confirm that for me, and get rid of any crap. Now it's going to be like, I expect there's a lot of dodgy results here because I've done a real approximate version of this query. So I need you, the re-ranker, to work double time at identifying rubbish results. So if you wanted to try this like semantic search strategy, you'd have to bear in mind that there would be costs per search. There'd be an LLM call to extract keywords. You've got to fetch more from lexical than you normally would. There's the work by the re-ranker. But that is fast to get started. I mean, in case the workings weren't super clear there, I'm just going to step through with an example because I have been loving my diagrams on this talk. Let's say you've got someone searching for, what are the advantages of using Tailwind CSS? Well, Stack Overflow right now, if you search for that, this will give you 0 results because it's a lexical search on the site, and we are aggressive in how we overfilter. For example, there might be great answers to this question, but it doesn't use the precise wording from the query. So what we'll do is I'll ask an LLM to extract the keywords that allows us to perform a lexical search. We can use an off-the-shelf model for this, like GPT-4o Mini. You can access that via OpenAI, by which I mean you can just make an API call over the internet. You don't need to like host the model, run the model, and there's none of that complication for you. You literally say, what are the keywords in this query, and it will answer. And in this case, it will say advantages using Tailwind CSS. We do a lexical keyword search on these keywords. Now, it's important to know that searching for just these keywords means we've lost a lot of context from the original question. So we're going to want to request way more results from the lexical search than we think we might need, because the results that are useful for the original query, they might be like 20th place in these lexical results, or 35th or 90th. So we take these overfetched, i.e. ask for a lot more than you think you might need, lexical results, send them to a semantic re-ranker. Again, off-the-shelf re-rankers are available. Here have one called re-rank 3.5, and like with OpenAI, you can just access this model with an API call. As I explained earlier, a semantic re-ranker improves the quality of search results by comparing them to the original query. So it looks through these overfetched, like very approximated lexical search results and probably identifies 90+% of them as rubbish. But of the remaining ones, it will boost the best ones to the top and the good, but not as good ones down a little bit. And we're done. Like, woo! But am I up here making search sound like a really hard problem when it's actually really easy? I mean, hopefully at least one of you is sitting here thinking, I could probably whip that up in an afternoon. Doesn't this sound too good to be true? Isn't semantic search wildly complicated to get right? Surely we need a vector database and a bunch of search specialists to produce anything worthwhile. If we're being honest, could this be as good as a vector search? Well, that is a very interesting question. What does as good as mean? To try to answer this, we need to talk about search performance. Now, in this context, performance is like how well does it serve the user, rather than how fast is it. Although that can have an impact on success. You know, if your search is incredibly slow, people will give up or avoid it. So let's talk about some of the ways that you might measure search performance. Let's say you had a lexical search system. My previous slides about how easy it is to experiment with semantic have inspired you. You knock up an experimental semantic search support for your product, and you want to be able to tell, does this actually make things better? Presuming you know your data at least a little, you'll be able to start by typing some queries into your prototype and seeing if the results look reasonable. You might then take a snapshot of your data. Maybe it's a cut down version, maybe it's all of it, but it'll be kept somewhere. It's not getting updated, so you're not getting a moving target for your testing. And then you can start writing down some of the queries that you've tried and trying to work out what data would be returned if you had a perfect search system. Then build some sort of test utility that passes each of your test queries into your exciting new search system and checks whether the results you expect are returned or not. It's very similar to building a suite of automated tests. Like for a given input, does the output look okay? This is called offline testing because you're doing it like in a special search system test environment. You're not doing it in production with real users. And there's a lot that's appealing about that. Like you can repeatedly blast it with test queries and then try to tweak it, X, Y, Z, blasting it again. You don't have to wait for real users to interact with it. So it's fast. And you can try lots of versions or iterations of your search that you want to see in action. And this this is a reasonable starting point. But to be really effective, you do need that knowledge of the data in your system, and you do need to know a little bit about how people tend to search within that data. If you don't have this, or if you want to go beyond your level of the understanding of the data or how it's searched over, you might take a different tack and see if any test sets already exist that might be relevant to you. Let's say, for example, you work in the tourism sector. There is a bunch of data sets that you can download about hotels. If you look on Kaggle, for example, it's this website, a data science community where people share data and resources and things. You can get raw data about products. When I say products, I mean data about things like hotels for a tourism website or questions and answers for a Stack Overflow-like site. However, you might find it harder to track down curated lists of search queries, as in the queries themselves and what products should be returned for those queries. Because aside from being kind of a subjective thing, it's also an expensive thing to maintain. So you can imagine that people might not want to share specifics like that. If they've gone to the effort of creating an industry-specific list of curated search queries, they can use it for themselves. That's like a competitive advantage. They had to invest a lot into preparing that. And even if they did share it, they might be selling access to that data. So it might come at a significant financial cost to you if you wanted to pursue that. The thing is, in the early stages of experimenting with search improvements, you might actually not need data from your precise domain. Bing data is this vast collection of information and insight gathered by Microsoft search engine, Bing. It has data on search queries, user behavior, click-through rates, loads of relevant metrics. So you can get an idea of what search results were considered good based upon what people actually clicked on. Now, this might be search data that's different to your data, but you can probably get a long way building a generic search, one that isn't tied to your particular content, and it's free. So we still get the benefits of offline testing, but with this big head start that there's a load of data available to you without cost for you to build your test suite. Another approach that allows us to create tests for our own particular data is to use the generative AI technologies that we're bombarded with every day by taking a selection of items from your data. And for each one of these items, ask an LLM to produce some questions that that item can answer. For example, if I'm looking at a Stack Overflow answer that explains how to do date serialization in JSON compatible with Python, I could ask an LLM to produce variations of questions that this answer should be able to answer. Then the theory is that if I do a search for any of those LLM generated queries, the answer I generated them from should be quite high in the search results if my search is any good. Now, this approach has the benefits of being fairly cheap. There's like one-off LLM usage costs for generating these queries to construct your test suite. And it has the benefit that it's your specific data that's being focused on. Now, the downsides are that it's not effective at generating queries that should not match. If you were building a test suite, you might want to include some cases where it's like, here's a query that really nothing should come back for. But this strategy is only really good for conjuring up queries where there are good results. Now, synthetic data is a massive topic that we could get into, but as I've already hinted at, we've got a lot today. Let's push on, because this is where things get interesting. Really, how your users experience your site is where the buck stops. Offline testing can be powerful, it's fast to experiment with, but it's basically hypothesizing. You don't really know what impact your changes will have until people interact with them. Do you see more instances of users getting search results and clicking on none of them? That doesn't sound like a good experience. Do you see users having to click on fewer results in order to find what they want, whether that's an answer that they upvote or they identify a hotel that they want to book or whatever a good result means for you? Now, on the downside, relying on user experience is much slower than offline testing. You've got to put the code out, you've got to see how users react, which means that there's another obvious downside, which is if you make things worse, you might have to suffer your users' wrath. Although bear in mind, That can be quite a valuable thing. Depending upon who your audience is, most users just go away if your site makes them sad. If anyone ever does give you feedback to tell you you've made things worse, this tends to be quite rare and quite valuable. If they don't tell you and leave. So it makes sense to try to use offline testing to quickly identify any obvious regressions, give you confidence that deploying is a good idea, and then trying to observe how it's received. So how can we do this? Well, if you were designing a product completely from scratch, you might be able to include like this nice, clean eventing system where you can report what's happening in the system. User A visits page B, which displays data about Hotel C and renders an availability calendar, and they search for dates D. And you might have something like Azure Event Hub configured, where you can throw events from your application into it, and it can get sucked into Databricks or whatever, where you can access the raw data, or you can set up indexes so you can perform interesting common queries on the user behavior quickly. But that might sound like a big faff and like an investment that you can't commit to without knowing what value you might be able to get back. So you might start by looking at data about user behavior that you already have. Maybe another team has set up eventing, which might give you a head start, even if it's not perfect for your use case. Or you might have access to traffic logs, which can offer some clues as to how people use your site. And I want to talk a little bit about traffic logs because they tend to be something that every company collects, and they can potentially be a goldmine. For anyone that's not familiar, traffic logs are records of every request made to a company or website or web product or whatever. Someone hits the homepage, it's logged. Requests an image, it's logged. Retrieves some JavaScript, it's logged. Submits a form, it's logged, it's dated. If you wanted to know how many searches are performed on your site each day, the answer could be here. Depending upon how your site works, it might even capture the search terms. And you may be able to see which requests come from one user or one session, so you can see what they did, how many pages they clicked into, how long they stayed on site. However, there is one thing to be careful about. If the traffic logs include any personally identifiable information, like it records user IDs and headers, and they can be associated with someone's name and address or any personal data, you need to be aware of data protection laws. This is a big topic, and I'm going to totally sidestep it by issuing that warning and by saying we're lucky at Stack that the people who look after the collection of the data allow the mere mortals access to it in responsible ways. Do you just need to see requests that don't have any even hint of personal data? There's a level of access for it. Fantastic. Do you want to be able to follow interactions within a single session, but you don't need to know who it is or risk being able to tie it back to us? There's a level of access for it. Amazing. The idea of considering traffic logs for this sort of thing touches on something that I'm a fan of, though, being scrappy. Like I said before, you probably wouldn't use traffic logs if you're doing a huge piece of work upfront to capture data and to understand what your users are doing. There's neater ways to do it, but there's obviously that big cost there, planning the data capture work and implementing it, which isn't to say that relying on traffic logs is without its costs, even on top of checking the legalities. Like one, for example, is that it's quite hard to connect the events that represent a single user's interaction with the site. The logs is just one long list of every access to every web page by every person using it, all mingled together. I won't spend time talking about how you might join that data up, partly in the interests of time, my favorite get out clause, and partly because it can vary so much from one company to another. It depends how you capture that data. But despite the challenges, it can be a place to start collecting clues and looking for patterns. I think it's really common to feel paralyzed by doubt and to worry about information not being perfect. But if you're going from a place of basically zero information to some information, it doesn't matter if it's not perfect. Let's start with what we've got. I was tempted to use the A word here, because I want to encourage iterating on simple experiments. But I've lost my train of thought. Because I want to encourage iterating on simple experiments, I want to talk about how we can leave worrying about collecting more precise data to the future if we experience success that suggest that we need even more data. But the word agile can elicit such strong opinions and preconceived notions I try to avoid, hence encouraging a scrappy attitude. Let's say that we were thinking about investing in semantic search, or thinking that we could improve our semantic search solution using a vector database. We saw earlier there are so many decisions. So where should we start? Anyone want an intermission? Because now is the allocated time. We are back in the room. And where were we? Oh yeah. Swish YouTube edit, can just go to here and it'll be like as if it never happened. Let's say we were thinking about investing in semantic search, or think we can improve our semantic search solution using a vector database. We saw earlier, so many decisions. Where should we start? Well, let's ask what sort of information would be useful in helping to determine what's working well, what isn't working well, and where we should consider spending our efforts. For example, what queries are being searched for? Like literally what things are people entering? What formats are these queries? Are they natural language? Are they keyword? Is there a proportion this much, a proportion this much? Is there a user type who prefers natural language over keyword? When we give search results, do users click on any results? Or do they immediately, if after they've done a search, try another search or just navigate elsewhere? Like, do these actions indicate a happy user? Are there any explicit actions that can be captured? Some products even have like a thumbs down or thumbs up, thumbs down. Has this done well? Has this content helped you? Explicit actions are valuable. It's quite possible you would be able to answer some or all of those questions by looking at traffic logs again, even if you can't find out everything that you might want to. Like, for example, it might be difficult to know whether when someone performed a search, did they not click on anything because it was all terrible results? Or did they not click on anything because it was zero results? And you might only be able to make rough guesses about whether the things people do next definitely mean they had a good time or definitely did not have a good time with your software. And let's not pretend either that being a data analyst is not like a full-time specialized job. It is. People do data at expert level all day long. And in general, being a software engineer is something of a different skill set. But we can invest a little time to pick up some basics because, again, we're in a position of not really using data to make decisions at all, then we probably only need to learn little and it will start opening doors. We can stop relying on someone having a perfect crystal ball that tells them precisely how to design products, a crystal ball that loses the company money when its conclusions are off the mark, which they always are to some extent, especially when these crystal balls are laying out work for us to do for the next 6 months. I mean, honestly, I think it's kind of arrogant to think that you can make the right decisions, all of them up front, particularly if you're doing anything slightly experimental or unknown. So it seems better to start with something reasonable and then test that and iterate it. But if you have no way to measure whether what you're working on is helping people, you don't have much choice other than to just cross your fingers and hope that you can plan to the nth degree based upon what you know about your users. And honestly, it is, I think it's so rare for people to actually understand users as well as they think. How many of the top dogs, the C-suite, the money spenders, the big decision makers at Stack Overflow use Stack Overflow? I wonder. Or I used to work at a web agency that produced tourism sites for like particular cities or regions. I don't think the directors used our sites. They might have used booking.com. They might have used hotels.com. Did they use those destination sites?
They downloaded this because at 3 a.m. he was checking it.
It was for recreation, not for business, and for making your life miserable, that he was so attention detailed, that one hypothetical person that my ex-colleague here is talking about. I don't think that our customers at that tourism website, building, place, The customers were tourism agency, like government bodies. I don't think they ever had any interest in mobile design, despite the majority of end users being on mobile and the majority of the money from on-site bookings on those sites coming from mobile users. But if you do find ways to find out how effective or not your work is, then you can try going in a few directions and see which ones really make sense. Then abandon the ones that don't, double down on the ones that do. What does it really mean to experiment? A/B testing sounds like it should be something super complicated. There's dedicated software to help you. There's methodologies, there's training courses to go on. But when we're just talking about getting off the start line, it doesn't have to be wildly complicated. When I looked earlier at like this useful information, this list of things, what would it be nice to know to measure whether our search is good? Let's say that we decide to measure how often does a user click on at least one search result after they do a search. Right now, the conversion rate doesn't seem great on our site, our product, whatever we're talking about, but we think we can try some things that may improve it. Now, we could jump in at the deep end and perform concurrent A/B testing where there's two versions of the search system live at once. Someone performs a search, they might go to search system A, or they might go to search system B, and we track the conversion rates for A versus B, and if system A is the regular search, and system B is the experiment, and system B, if its conversion rate is better, system B wins. There's nuance, but that's the gist. But if you're not set up for that, which is a lot, if you're not set up for that, you could run system A for a week, and then you could run system B for a week, and you could compare the conversion rates after those weeks. Instead of running your A/B tests at the same time, we're running them at different times. If we want to sound fancy, like we know what we're talking about, and like we want to sell this to people who don't necessarily agree with our ideas, we call this temporal segregation, as opposed to user or group segregation. Now, there's some possible gotchas with temporal segregation, like there's no rule that says it has to be a week and a week. But if your website sees different traffic on weekdays than weekends, then probably comparing a 3-day stretch of Monday, Tuesday, Wednesday against Thursday, Friday, Saturday is probably not going to be comparable. Or if you're seasonal traffic, like again, I'm thinking about my old tourism job, the week just before school holidays compared to the first week of school holidays might not be comparable. Minimizing these gotchas are easier if you have some knowledge about how your product is used. But if you don't feel like you have intimate knowledge to be able to avoid all of those problems, that doesn't need to put you off entirely, because we want to be scrappy. Temporal segregation may have some compromises, but concurrent A/B testing has costs unless you're already set up for it. And some useful measurements are better than no useful measurements, as they allow us to experiment and to find out what really works. Which brings me back to the question I posed earlier. Is it really possible that the quick and dirty way of implementing semantic search, where you don't need a big, expensive vector database, could be as good as if you do have a big, expensive vector database? I mean, surely the big, expensive vector database, big and expensive for a reason, right? And it's almost certainly going to involve more than a one-off purchase price. There'll be ongoing licensing costs. There's work to integrate it with your product. There's going to be ongoing maintenance, because there always is. Purchasing a vector database for the purposes of implementing semantic search in your product is going to be a project. The completion of that project is going to be an output. We did it! Woo! Pats on the back for everybody involved, but we don't care about outputs. We care about outcomes. We care about whether our work is making our users' lives better, which usually means that we end up making more money one way or the other, which is generally the point of most companies. So to even ask whether a semantic search can be effective without a vector database is to kind of presume that an embedding vector search is best for your needs, and it's a compromise to not have one. Based on what? What measurements do you want to see in terms of user behavior if you were to improve your search? If we wanted to, I bet we could pick holes in the measure that I just suggested, like what percentage of search results results in the user clicking on at least one of the results from the search. But I think it's a much more meaningful measure than what percentage of searches are served using a vector database. Now, I don't mean to suggest that it's easy, by the way, to come up with these sorts of measures. For example, Early on in the Stack Overflow for Teams, semantic search planning, one of the proposed things to measure that we wanted to see increase was number of searches performed. Premise being, people struggling to find what they wanted with our existing search. And so they weren't using the product as much as we'd like. But I disagreed with starting with this measurement because, yeah, there are users who aren't using Stack Overflow for Teams at the company where their company's paid for it as much as we'd like because they struggle to find what they need. If our search is better, hopefully they'll use it more. Number of searches performed increases. Okay, but we've got users who are succeeding despite our search. They're probably adept at formulating queries and tweaking them when they can't find what they want on the first attempt. If our search is better and they find things on the first attempt without having to tweak and retry, we should be expecting those people to perform fewer searches. So the number of searches decreases. Is that a failure? Well, I don't think so. The thing is, like I say, I'm not saying it's easy, but as with lots of things that aren't easy, the way to get better at them is to try. Experiment with how you define outcomes as well as you experiment with how you achieve them. So earlier I told you how we tried adding semantic search to our public website. It wasn't a great success because the biggest problems on stackoverflow.com isn't finding somewhat related content. It's about servicing the best content, looking at upvotes, recency of answer, blah, blah, blah. If we were to pick up that project again, there could be an argument made that semantic search technology, embedding models, etc., have come on such a long way since then, and so we could make the semantic search by going deep into research like on that. But we don't want the best semantic search. We want the best search. What does that mean? What's the difference? Well, the first is the technology. It's a way to execute part of the search process. The second is about the experience that the user has. If we can whip up a really quick, easy way to implement semantic search, is it worth us spending our limited time making that part of the search better? Or is it best that we spend it on other aspects, like incorporating the metadata quality signals? The more we can experiment and measure, find out what works and what doesn't work, the better we can spend our energy, and we might even realize that we understand the problem even less well than we thought we did. Because one of the fun things about raising the bar in technology is that user expectations rise along with it as they get used to this new normal. So like I said before, everyone's used to giving natural language queries to Google, so they're used to giving natural language queries to lots of search interfaces. And as we get used to using natural language to search for things, we increasingly expect it to understand the intent of the question as well as being clever in how it matches text content within documents. So if I was to search Google for what new OpenAI models were released last month, I don't want you to be clever about matching those words to documents. I don't want April 2024 articles about models that were new in March 2024. I want you to understand that last month is a filter about when the data I'm interested in is pertinent to, and that data should be about new OpenAI models. I mean, this next example hopefully really goes to show how quickly expectations leap up without even really, users being aware of their behavior changing. If I ask my phone, it's always listening, so, is the tunnel going to be closed tonight? I expect it to know. Tonight should be interpreted as a filter on the content to look over, not a word to look for. I did say I prepped the content a couple of months ago. It's not June 14th. I expect it to know the tunnel means Birkenhead Tunnel based upon, I don't actually know. My location, my search history, magic. And I bring up these complications, not to say that a good search has to address them all, but because it's important to know how people are using your software. If you need a search that supports features such as recognizing what query terms should be interpreted as metadata filters rather than words to match in your content, like last month in the new OpenAI models example, or if the user's interaction history on the site should influence their results, like should we boost C# results for this user because their user history is just like C#. Spending time wringing your hands worrying about whether semantic search implementation, which is only matching content in your data, it's not doing these other things, worrying about whether that's optimal, probably time you should be spending elsewhere. Speaking of needing to know about what your users need, didn't I say earlier that nobody uses our site search? Well, yes. But the search bar is just one way to search. It's often the only way that people who are like less technical think of when we say search. So I've been trying internally to like use this phrase content discovery, where search bar initiated search is one slice of that, which suggests there are other types of content discovery. Let me tell you a little bit about Stack Overflow's tag search pages. These are a feature of the site that are used by people actively looking for questions to answer. And you might all be really familiar with this, but I want to not presume knowledge. These are commonly used by people who are looking for questions to answer. And like, first up, thank goodness that these people exist. For whatever reason, they want to provide solutions to other people's problems. Part of my team's focus this year has been making their lives easier because historically, I do not think that's been the case at Stack. So I just want to quickly sort of recap, jump into what tags and tag search pages are. Every question asked on Stack Overflow is tagged. That means it has at least one and as many as 5 tags that were assigned by the person who asked it. These tags come from a pre-existing list. You can't just make up a new tag when you ask a question. The idea is that these labels, which is what tags are, they help people who might want to answer your question find your question. Because the most common way that these beautiful, generous answer writing people find questions to answer is going to tag search pages. You can search for a single tag. You can search for multiple tags. If you search for multiple, the questions that are shown must have all of those tags. This allows you to be specific about the sort of questions that might be interesting to you, or what areas of expertise you have. You might be someone who is into TypeScript and GraphQL, which are 2 front-end technologies that are often used together. There are different ways to order these results on the tag search page. The most common is newest, ordered by how recent the question was asked. The newer a question is, the less likely it is to have been answered. And people like answering questions with 0 answers because they don't want to feel like they have to compete with someone else's answer. They want to be the best answer person and get all the glory. More power to them. But newer questions are also less likely to have been looked over by site moderators. And so they might be lower quality questions, meaning that they're not well written or they don't have a nice way to reproduce the problem. They might be questions that moderators are going to come along and when they see it, they're going to close it. They're going to be, this has already been answered somewhere. We don't think this belongs on this site. You're asking about coffee, not software. Viewing questions that are hard to answer because they don't include enough detail feels like a waste of time. Answering a question that a moderator is going to close means that your answer might basically disappear when that happens, which would be sad. So some people prefer the active tab. This is ordered by when questions were asked, or when someone commented on them, or upvoted, or downvoted, or someone answered them. And if a question has some activity on it, it's more likely that a moderator has seen it. It's less likely, if they've seen it and not closed it, it's less likely that they're going to close it. And so it's less likely that if you answer it, you're answering a question which is going to get closed. However, it's also more likely that someone else has already answered it. So how about the unanswered tab? The unanswered view. Surely this will help. This sorts questions according to how many upvotes they've had. An upvote on a question is supposed to be a way of saying, nice question, well written, looks interesting. If the questions are upvoted, hopefully they're unlikely to be closed by moderators. And if they're unanswered, you're going to be the first to answer, like tick, 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 tick. However, sorting by votes might mean that you get really old results. The older the question is, the more chance it's had to be upvoted, and maybe the question has gone unanswered for this long for good reason. And also it turns out that unanswered means 0 answers or 0 accepted answers. So a question might have an answer, but the person who asked it never came back to say thanks. There is a logic there. The idea is that these questions would still benefit from an answer because someone asked it, someone answered it, the person who asked it wasn't impressed by the answer, they could still do with an answer. It's unintuitive to me. Worse, I think actually it suggests some of these questions are written by people who ain't going to come back and say thanks. Having a fixed list of tags is also a limitation. It puts the burden on the person asking the question to choose good tags from the options available. So sticking with our imaginary person who's into TypeScript and GraphQL, they might also find interesting questions if they search for tags like Angular and Apollo client, because Angular is written in TypeScript. Maybe they can often help there. Apollo client is something related to GraphQL. Some questions will be tagged with Angular and TypeScript, but some won't. So the little red arrows on this example question are pointing at a question that's tagged Angular and Apollo client, but not TypeScript nor GraphQL. And so this would not come back in the search results of the person who's searching for TypeScript GraphQL, which is sad because that TypeScript GraphQL person might be able to help with this question. They might want to help with this question, and we've made it hard for them to find it. It's like the options on the site are all quite deeply flawed, and we're making it tough for these generous people to find questions to answer. How much of their goodwill are we throwing out the window because we make it hard for them to find things? This does not to me sound like we understand our users. Maybe people loved this 15 years ago. Maybe a small number do right now. But everything from personal anecdotes to user surveys, to user interviews, to user behavior analysis consistently support the notion that we're failing most people. And so we're failing ourselves, we're failing our business. So back to my team's focus on trying to make these people's lives easier. We imagine that we'll be able to help people who are looking for a question to answer. Help them find questions that they think are interesting by looking at their history on the site. What questions have they answered in the past? What questions or answers have they viewed or upvoted or downvoted or commented on? Are there any patterns to be found around subject matter, or whether they seem to be quick to answer questions, or are they big, meaty, technical questions? When looking for patterns, we might find that semantic search capabilities help us. Or we might find that we can achieve greater results trying to classify posts according to content, like this is about TypeScript compiler optimizations. This is about Angular 19 directives. Or maybe we can classify posts by level of complexity. Do you like answering quick to easy, quick to answer questions? Or do you like these big, meaty ones? We could classify by the people asking, because some people like helping newbies who don't always structure a question very well. They like supporting them and helping them, and others are less patient and want to avoid those. Then we could use these sorts of attributes that we've used to classify questions. And we could say, this user online right now, has answered questions that have attributes X, Y, Z in the past. If new questions appear with similar attributes, maybe we should highlight them to that user, whether we boost their ordering in questions lists or whatever. But to find out, we want to identify what user behaviors to support and encourage. And to do that, we need to know what we're trying to achieve. And again, we care about outcomes, not outputs. Like I said earlier, measuring success by counting how many things did we ship is looking at outputs. Well, department XYZ's quarterly profit increased by 10% is an outcome. The first might be a way to indicate progress. But if that's all that you measure, then you might be looking really productive on paper and achieving nothing of any actual value. So from the perspective of my team, we wanted to match question seekers to questions. Question seekers are these people who are looking for questions to answer, the tag search page people. Match question seekers to questions so that we get more answers, and we want to have more of these brave askers get what they want, because Stack Overflow has a reputation for being quite aggressive, abrasive place, with good reason. I think the people who ask questions for the first time, they muster that courage, hoping they're not going to be told to go away. I think it takes a lot. And imagine they don't get an answer. I want more of those brave askers to get an answer, so they're more likely to come back and ask more questions. Question seekers, I want you to find more things to answer that you care about. People who want to answer questions, I want you to feel good about asking questions and getting answers. And let's zooming out, think about it from a business perspective. They want more questions and answers. They also want more signals about the quality of content, the votes, whether it's a flag that this is off topic or better discussed elsewhere. They also want to know more about how users interact with the data. Because this should result in a better return on investment for our users, people asking questions more often get an answer. People looking to answer more often find interesting questions. And this is like causal loop. This one feeds into the other. It's like positive feedback. But we also have partnerships with big players like Google, Microsoft, OpenAI that include data licensing, where they use data, our data, ours and theirs, this licensing, to train ML models. If we stop accumulating raw data and the quality signals around it and how the users interact with it, we won't keep those partnerships. They won't keep giving us the money. So it starts at the top. Yes, we care about the users. That's what my team does. And it filters into why it's important to the business outcomes. I feel a responsibility at this point to share something else with you about user behavior. It tends to be a moving target. I mentioned before that user expectations often increase in lockstep with software's abilities, but user behavior can also vary if they try to sort of sidestep changes they don't like, or if they had ways of working in one version of your software that you might not have foreseen, but which they kind of ingeniously discovered worked, and then you make a new release and it no longer works. Or if we're being really optimistic, you realize they're doing this Rube Goldberg approach to your software, and you make this lovely streamlined approach in your new version. It changes their behavior. I mean, in the physical world, you see this when road layouts change, whether the road is being dug up and there's temporary traffic lights, or there's permanent changes made to the road layouts, changes made to traffic light patterns that alter traffic flow, lower speed limits introduced for safety reasons or air quality, whatever it is, where they demand I drive slowly now. I'm kind of fascinated actually by this sort of thing, and it always makes me think of, I promise I'm not just wasting your time with endless tangents, always makes me think of the film Mission Impossible 3. Early on, Tom Cruise is at a party pretending to be all normal, and his cover is that he is not a high-tech, secure room break-in slash crane killer slash whatever ludicrous stunt attached to a plane or building he does himself. Oh no, he's worked for the Department of Transport for 10 years, studying traffic patterns. And the idea of this cover is it's so boring. He does not need the deepest cover story, because when someone asks, oh, what do you do for the DOT? He gives them a little spiel, drops the conversation by going to go and get them top-ups for their drinks. And as soon as he turns around, the guy he's talking to like rolls his eyes. He's like, I honestly think this is so interesting, like trying to simulate currently observed behaviors and predicting what to expect if something changed. And I bet it's quite hardcore in terms of the software, the modeling, and it requires a deep understanding of the psychology of drivers. If it had been me at that party when Tom Cruise would come back with a drink, I would have had so much to ask him, which I'm guessing would not have ended well for me. Let's get back to software. One example I shared earlier about user behavior changing over time. Back in the day, we all used to exclusively perform keyword styles in Google. But a shift occurred, and now it's not default. Now natural language queries are expected to work. They require less thought on the part of the user. Just ask Google or ChatGPT or whoever your question. Don't try to second guess the system. Don't try to second guess what magic words to use or to avoid in the hope of it doing its job better. When search engines weren't good at dealing with natural language queries, people didn't use them. Now they are good, user behavior has shifted. Observing user behavior can tell you what happens now, but it can't tell you why. And it won't let you reliably predict what will happen if you change something. It will hopefully give you enough information for you to hypothesize why behaviors exist and what you might try in order for you to change behaviors you want to. But then you'll have to keep observing and see if things do change. See if they changed in the way that you hoped or not. And users can show astonishing ingenuity in the ways they'll do things the way that they want. Might not be what you wanted or expected. One more example of this, online advertising. Some years ago, it seemed like you couldn't move on the web for horrible loud ads flashing at you, and we became desensitized to it. People have realized that ads that are less showy, whether it's simple Google ads, like Reddit ads, sponsored tweets, often do better. Like ugly ads can sometimes fool our ignore this ad nonsense brain filter, such we see them again, which seems mad. Surely beautiful is better. And there are plenty of ad agencies very happy to reassure you with that and take your money in exchange for beautiful ads that do not result in clicks because they haven't been created with real user behavior in mind. I mean, this is a great example of, I think, if you actually analyze user behavior rather than theorizing about it from afar or presuming you know it all already, the crystal ball is back, you might find behavior that surprises you. Historically, research teams at Stack had categorized our users into personas such as learner, someone who wants to find information, solve their problems, or helper, someone who wants to help someone, like by answering questions. When my team's focus changed at the start of the year away from Stack Overflow for Teams to our public CProd sites, like I questioned this because I was like, myself as a user, sometimes I land on Stack trying to solve my own problem. Sometimes I come to Stack looking to answer a question. Same me, same user, multiple personas. However, as I look at like user patterns, traffic logs, I found something surprising. People don't even limit themselves to one persona per visit. Like they don't arrive as one persona and do their thing and leave. It's common for people to arrive from Google or wherever trying to solve their own problem, read some content, and then decide, here, why don't I just check for any new questions on one of my favorite tag search pages that I might want to answer? In fact, a third of answers come from people who arrive as a solution seeker. That is someone who wants to solve their own problem. And then they switch to this question seeker mode and they find a question that they answer. A third of answers comes from that type of experience. That's a lot of answers. It's a lot of the answers that we receive. This insight was brand new to us. These here people are a segment of users that we didn't realize existed, or if we did, not in any significant numbers. And my team's quest to match question seekers to questions has the potential to be really awesome for these users. Because it opened the conversation a bunch of new ways. Like, let's take this as an opportunity to look hard again at reward and motivation. We historically relied upon reputation or rep as the reward for people helping others. It's like magic internet points that don't mean anything. And I know that rep has never mattered to me on the few times I've answered something. And I've heard the same from people that we've interviewed at Stack about how they use it. People sometimes use it as a way to like test knowledge about something they've learned. Oh, I've just learned this facet of library A. Do I know it actually well enough to answer someone's real world question? Or we heard from one person who really loved library B and they wanted to help build the community for that. So they wanted to see where people had questions. They wanted to answer those questions, give those people support, bolster that community because they loved that product so much that they wanted that product to do well. So maybe people do feel motivated, but by things other than rep. So could we use the interview data to support like low investment experiments into like notifying answer writers about their impact? Like, hey, you wrote an answer last week and you're back today because you're trying to solve a problem of your own. You linked in from Google and you got a little pop-up going, hey, thanks. X people, 100 people viewed your answer that you gave us last week. Or person, 12 copied code from your answer in the last couple of days. Could we even like include a link to similar questions in that message and see how people respond? Hey, thanks so much for that. Based on everything we know about you, maybe this question would also pique your curiosity. Maybe it wouldn't, maybe it would, but we try something small and simple and experiment. Or maybe we look for other ways to draw people to the site and see if many of them become a while I'm here answer writer. We have blog posts that we market, brings people into the site. There's been this whole experiment about coding challenges posted on LinkedIn, brings people into the site. We have this little known chat site somewhere in the site. Bring people in, can we convert any more of them? If this conversion pattern exists, or we're wasting the opportunity by not encouraging it. And it also really reinforces how important it is for us to adapt to changes in the industry. As people click through less to search results because they get an AI summary from Google, or because they ask ChatGPT or Perplexity directly, we're getting fewer people landing on the site, and so there'll be fewer, while I'm here, opportunities for us to help people find questions to answer. Let me raise one really concrete example of something I'd love to see experimented with: the reputation threshold around upvotes. Originally, rep was supposed to be a way for us to reward people for creating content on the site, particularly good content, because you get rep whenever someone upvoted your question and answer. It was called gamification, and it was quite a new concept 15 years ago. But it very quickly morphed into also being a measure of, do we trust you? So you can't actually upvote someone else's answer unless you have, I think, is 15 rep. So if you're just an average person, you've linked into us from a Google search results, and you try to click the upvote arrow to say, hey, thanks, this really helped me out, then the system goes, get out of here, you don't have enough rep to say thank you. Your opinion is meaningless to us, which makes me feel like, what? Someone wants to say thank you and the site is like, I don't even believe you're a real person, go away. Like, I strongly suspect that person is not in the future going to try and say thank you again. Now, not only did we treat that person badly, we also denied the upvote to whoever wrote that answer. And we lost a quality signal that, cynicism ahead, has value for our data licensing partnership customers. Rep was treated as this easy way for do we trust you, but it's far from the only tool. Like, why don't we look at traffic patterns and be like, hey, if you visited 50 times this year, 12 different questions, you're probably a real person. You're not a sock puppet account which someone has created to upvote their own answers for reasons. We could retroactively look at traffic patterns from users whose upvotes were rejected due to insufficient rep and see how many of them fit patterns that we think suggest real person and how many of them suggest bot or sock puppet. We could use the user interaction data that we already have and experiment to try to be less rude while low rep users, bring more quality signals to our community, collect more data for our data licensing deals. We've been stuck in this rep-driven mindset, and user behavior has changed. We should change. Now, I joked before about not calling this agile, and I still don't want to get into that whole debate to worry about what it means to one person or means to another person, but I think its origins there are some common principles in the things that I'm talking about here. We don't really know the best way to achieve things. And at the start of a project, we know the least about it we ever will. We can hypothesize, but the sooner we can measure impact, the sooner we can know how to proceed. Maybe our scrappy first attempt is actually good enough. Let's move on to something else. Maybe our first attempt is terrible and unearths a huge flaw in our understanding. Or maybe it's a good start and we should carry on. And then we should hypothesize how we might do even better in this direction. I've already said that I think it's arrogant to believe that you can conjure up the best way to do something. I think it's possible to scheme away and come up with something good, but it may be much more luck than judgment as to how much you over-engineer something or how much potential you waste. Frequent course corrections are more likely to lead you to greatest success. At Stack, our CTO, well, became our CTO and CPO. So he's Chief Technical Officer, Head of Engineering Land, and Chief Product Officer, Head of Product People. He started a book club with product management to try to help them shift away from this old-fashioned, we know everything, we don't need data or measurements before or after we instruct engineering what to do, to something more like I've been talking about. The book that they read, and which most of the company then also read, to be honest, was called Continuous Discovery Habits and was written by Teresa Torres. It's a very approachable book and it's easy to dip in and out of, or you can read from front to back. She talks more about how you can hypothesize, about how you might make improvements and try to find data that supports it before you even do your experiments. Like, do we actually see the user behavior that this work is predicated on when we look at the traffic logs or whatever? Maybe the data will refute it. If so, wonderful, we just saved ourselves wasted effort based on faulty assumptions. Maybe the faulty assumptions can be adjusted for and the plan can be changed. Either way, we avoid committing to a wild goose chase. And that really is what I want you to talk about here. Like, how do we do work that really moves the needle? Because I don't want to do work for the sake of work, but how do we know if it's having an impact if we don't measure? And that is finally it. If anyone's desperate to revisit this, the slides are available at the QR coded link. There's a references slide at the end that links to some demo code and some of the resources that I mentioned if we've got time, which since everyone's packing up, I'm not sure if we do. I'll happily take questions. Thank you very much. All right. Really?